I'm going to start with the quadratics page that you had to do for homework. You had to do 5 through 7. It says to use the quadratic formula. It also tells you that you're going to end up getting imaginary roots, so just be prepared for that. So here we go. Number 5. We've got x squared minus 4x plus 13 equals 0. Quadratic formula, x equals negative b. That's a weird 4. I don't know why my board does that. It's so annoying. 4 plus or minus the square root of b squared. Remember, the negative is in the parentheses. It is also being squared. B squared minus 4. A is 1. C all over 2a. So that's going to be 4 plus or minus the square root. Negative 4 squared is positive 16. Minus 4 times 3, 4 times 13, sorry. 4 times 13 is 52. All over 2. 16 minus 52 is negative 36. Alright, so this is how we know that we're going to end up getting imaginary roots because we have a negative under the square root. We can take care of that by saying that this is I times the square root of positive 36, right? Anytime we have a negative under the square root, you can pull it out by using I. Come up here. And then I can actually take the square root of 36. So this is going to be 4 plus or minus 6i all over 2. And then 2 can cancel into both of these. Here you're left with a 2. Here you're left with a 3. So the answer is 2 plus or minus 3i. Number 6, we've got 2x squared plus 2x plus 1 equals 0. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's going to be 4 minus 8 under my square root. And then that's going to be negative 4. And since we have a negative under the square root, we can take it out by putting an I there. So this is going to be negative 2 plus or minus I. And now we have the positive square root of 4. But we know the square root of 4, that's 2. So this is equal to negative 2 plus or minus 2i all over 4. And 4 goes into here once, and I'm left with the 2. So the final answer is negative 1 plus or minus I. You can write 1i if you want, all over 2. Which, if you wanted to, and you don't necessarily have to, but we have this fraction right here, you could break it up like this if you want. It's the same thing, just so you are aware of that. And then I'll erase this so we can do 7. So 7, we've got x squared plus 10x plus 29 equals 0. So x equals negative b plus or minus the square root of b squared minus 4, a is 1, c, all over 2a. 10 squared is 100. 4 times 29 is 116. So now I've got 100 minus 116 under my square root. So this is going to be plus or minus the square root of negative 16. And we can take care of the negative by pulling out an I. And now it's a positive square root. And then square root of 16 we know is 4, so this is negative 10 plus or minus 4i all over 2. And then 2 can go into here 5 times, and it can go into here 2 times. So the final answer is negative 5 plus or minus 2i. Pretty easy. On to the next page is the probability. You got to do 7, 8, 9. 7, a standard deck of cards contains 52 cards divided into 4 suits. There are 2 red suits, hearts and diamonds, and 2 black suits, clubs and spades. Each suit contains 13 cards, ace, king, queen, jack, and cards numbered 2 through 10. Woo! A card is drawn from a standard deck without replacement. What is the probability that the card is a king? Now, fun fact, on the Regents exam, they expect you to know all this information about cards. They expect you to know that there are 52 cards in a deck. They expect you to know that there are 4 suits. They expect you to know that there are 13 cards in each suit. So they're not always going to give you this big spiel about what's in a deck of cards. Okay, so you do actually need to know the whole 52 cards, 4 suit stuff. Anyways, probability that I'm pulling out a king. Well, how many kings are there total in the deck? There are 4. There's 1 for each suit, so there are 4 kings that I could grab out of a total of 52 cards that I could grab. So the answer is 4 divided by 52, which does simplify into 1 over 13. Right? For 8 is very similar, but now we have 2 cards that are drawn from a standard deck of 52 without replacement. What is the probability that both cards are kings? Well, we just figured out the first draw. The first draw, the probability of drawing a king is 4 out of 52. Now when I go to draw my second card out, how many kings are there for me to grab? Well, I already took one out, so now there's only 3 possible kings. And since I took the card out, I don't have 52 cards anymore, I have 51. And I want both of these to happen at the same time, so the counting principle says you multiply. 4 times 3 is 12. 52 times 51 is 2,652. And we could do 12 divided by 2,652, because I'm pretty sure that's going to simplify to 1 over 221. Cool. 9, almost the same thing, except now we're drawing 3 cards instead of 2 cards. So now we're going to have 4 out of 52, the first king. The next king is going to be 3 out of 51. And then the third time I draw, well, I've already drawn out 2 kings, so I've only got 2 left. And since I've taken out 2 cards, now I'm down to 50 total cards. So we've got 4 times 3 times 2, which is 24. And then I've got 52 times 51 times 50. This is going to be a big one. That is 132,600. Woo! And if we simplify that, we get 1 over 5,525. All right, but really not too bad. And now here's the bad stuff. All right, sketching a cycle of a trig function. We had to do 29, 30, and 34. 29 and 30 are pretty easy. 34 is kind of tough. All right, but let's start with 29. We've got y equals the sine of 2x. All right, looking at this function, let's just kind of jot down what we know. For instance, I know that this is really like a 1 out here. This is a 1 sine 2x. So my amplitude is 1. All right, that's how high my waves are going up or down. And then I have a 2 on the inside. 2 is the frequency. So the frequency of this curve is 2. All right, so that means that by the time I go from 0 to 2 pi, this thing needs to happen twice. Remember, we can also figure out the period. The period is how long it takes for a curve to go through 1 cycle. And I need to know that because the directions tell me to only sketch 1 cycle. All right, so to find out my period, I'm doing 2 pi divided by the frequency. And in this case, my frequency is 2. And these cancel, so the answer is pi. So that means that by the time I go pi units, I should have completed 1 cycle of my function. So let's go ahead and draw that. All right, I'm not going to go all the way to 2 pi because by figuring out the period and the instructions telling me I only wanted to go 1 cycle, I only care about going as far as pi. All right, and I know what's in the middle of pi. That's pi over 2. And I know that my amplitude is 1, so I'm going to go up and down to 1. And now let's plug some stuff in. I can plug in 0. All right, so y is equal to the sine of 2 times 0. Oops. Which 2 times 0 is just 0, so this is the sine of 0. We're using our unit circle. 0 degrees is right here. The sine value there, my y value there is 0. So this is just 0. So at 0, I'm at 0. Now let's figure out pi over 2. So I've got sine and then 2 times pi over 2. The 2 and this 2 cancel. So you're just left with the sine of pi. All right, remember pi is 180 degrees, so on my unit circle, I'm over here. The sine value there, the y value there is 0. So this is also equal to 0. And next I can plug in pi, so this is going to be the sine of 2 times pi, or 2 pi. On my unit circle, if I go 2 pi, that's 360 degrees, so I end up right back here. And the sine value there, the y value there is 0. But we know that sine curves are not straight lines. All right, they need to go up, they need to go down, they are waves. So we'll go in the middle of pi over 2 and pi, and 0 and pi over 2. All right, we're going to cut these in half. And half of pi over 2 is pi over 4. So that's going to be 1 pi over 4, and this is going to be 3 pi over 4. Remember, pi over 4 is 45 degrees. You do need to know this. Give myself some more room. Now I can figure out my pi over 4s. So now I've got y equals the sine of 2 times pi over 4. The nice thing is that this 2 will cancel into the 4 and I'll be left with the 2. So really I'm figuring out the sine of pi over 2. Pi over 2 is up here on the unit circle. Pi over 2 is 90 degrees, and the sine value there, the y value there, is positive 1. So here at pi over 4, I'm up here at 1. And if you want to plug in 3 pi over 4, you're more than welcome to. But we know that if my sine curve is going up, it's eventually going to have to come back down. So I'm going to be down here, and then I can just fill in my curve, not being pointy, and there you go. By the time I go pi units, so by the time I go a length of pi on my x-axis, I completed 1 cycle of my sine curve. Cool. Now let's do 30. Weird. Alright, 30. 30, I've got y is equal to the sine of 1/2 x. Again, it doesn't have anything out in front. This is like a 1 out in front. So my amplitude, again, is 1. My period is my frequency is what's being multiplied on the inside. So this has a frequency of 1/2. So by the time I go to 2 pi, I'm only going to complete 1/2 of my sine curve. All right, and so then to find out the period, and remember the period is how long it takes to complete 1 cycle, I'm going to do 2 pi divided by the frequency. Now you can put 2 divided by 1/2 in your calculator, or just remember, I got a baby fraction here, let's get rid of the baby. So multiply by 2, multiply by 2, you get 4 pi. So in this case, our graph is going to have to be really wide because I have to go 4 pi before this is going to complete 1 cycle. So let's go ahead and draw this. Alright, and I need to go 4 pi because that's how long the period is. So this is going to be 4 pi. Whew. Halfway between 0 and 4 pi is 2 pi. Whew. Halfway between 0 and 2 pi is 1 pi. And this is going to be 3 pi. And then I know my amplitude is 1, so this is going to be 1, and this is going to be negative 1. And now we can go ahead and plot some stuff. I'm going to plot 0. So the sine of 1/2 times 0, which is just the sine of 0. I'm here on my unit circle. At 0, what is my y value there? It's 0. So here I am at 0, 0. Next, I will do pi. So that's the sine of pi over 2, which we know is 1. So at pi, when I plug in pi, I've got the sine of pi over 2. Sine of pi over 2 is up here, 90 degrees. Sine is the y value. The y value at 90 is 1. So I'm going to be up here at 1. Next, I can plug in 2 pi. Y is equal to the sine of 1/2 times 2 pi. Here, the 2's cancel. So really, this is the sine of pi. Pi is 180 degrees. 180 degrees is right here on the unit circle. The sine value, the y value, is 0. All right, and as you can see right now, I only have the first half of my sine curve between 0 and 2 pi. And that makes sense because my frequency is 1/2. All right, 1/2 because 1/2 of the cycle happens between 0 and 2 pi. And again, we can plug in 3 pi, we can plug in 4 pi. And remember, looking at your unit circle, if going here is 1 pi, and going all the way around would be 2 pi, if I go again, that would be 3 pi, and then this would be 4 pi. So 3 pi, you get the same thing as 1 pi, 4 pi, you get the same thing as 2 pi. Or we can just know that my graph is going to have to dip down and then come back up to 0. So that is this curve. It's very fat, it's very wide. And now 34. 34 is tricky. 34 is tricky. Get rid of all this crap. There we go. Okay. So 34 is y equals 1/2 the cosine of 1/3 x. All right, so first things first, I've got a 1/2 on the outside. So that means that my amplitude is 1/2. So my curves are only going to have a height that is 1/2 units up or down. This part on the inside is my frequency. So my frequency is 1/3. So that means that by the time I get to 2 pi, I'm going to only go through 1/3 of my curve. Ugh. And then I can figure out my period. How long is it going to take to get through an entire cycle of this graph? Remember, period is 2 pi divided by the frequency, so that's 2 pi divided by 1/3, which you can put in your calculator or just get rid of the baby fractions, and we get 6 pi. So if we thought our other graph was going to be super fat, this one's going to be even more fat because it's got to go from 0 to 6 pi in order to get one period, one cycle of this function. So here's going to be 6 pi. Halfway to 6 pi would be 3 pi. Now, I don't want to, halfway to 3 pi is what, 1.5 pi? I don't want to do that. You guys know that I don't like fractions. So instead what I'm going to do is I'm going to take this and I'm going to divide it into thirds. So here's going to be 1 pi, here will be 2 pi. To me that's nicer. So then here will be 4 pi, and here will be 5 pi. Alright, just seems better to me. And then my amplitude is 1/2, so I only need to go up by 1/2. So here, I'll put a 1 and then I'll put a 1/2. It's up to you. If you just want to put the 1/2, that's totally fine. All right, and now let's plug in some stuff. So, and I'll draw my little unit circle up here, just for future reference. So, let's start with 0. So, y is equal to 1/2 the cosine of 1/3 times 0. So that's just going to be the cosine of 0. And the cosine of 0 degrees is right here. What is the x coordinate there? The cosine value there, that's 1. So this is going to be 1/2 times 1, which is 1/2. So at 0, I'm right here at 1/2. Cool. We can go ahead and plug in pi. That's fine. It's going to be kind of messy though, because we have 1/3 times pi, which is 1/2 times the cosine of pi over 3. All right, pi over 3, we do know a value for pi over 3. Pi over 3 is 180 divided by 3, so that's 60 degrees. And we know values for 60 degrees because we have our special right triangles, right? All right, we do know that. And the cosine of 60 is a over h, so 1/2. So this is 1/4. All right, and do I expect you to do this? I mean, I do expect you to kind of know the cosine of pi over 3, and you could put it in right here if you want. But I think I mentioned this in class. If you get something that's really, really crazy, move on. Maybe you're going to need to plot it. Maybe you're not. Let's try something else, like 2 pi or 3 pi, something like that. So I'm going to erase this stuff over here. Okay, and you might be noticing that if I plug in 2 pi, I'm also going to get something a little weird. Okay, so if I do y equals 1/2 the cosine of 1/3 times 2 pi, so this is going to be 1/2 the cosine of 2 pi over 3. 2 pi over 3 is 120 degrees. We do know how to figure that out because 120 has a reference angle of 60, but let's see if we can do 3 pi. Maybe 3 pi will be nicer. So let's try 3 pi. Y is equal to 1/2 the cosine of 1/3 times 3 pi. And this is nice because these 3's cancel. So now you've got 1/2 the cosine of pi. And the cosine of pi, well, pi is 180. That's over here on my unit circle. The cosine value there is -1 because that's the x value. So this is 1/2 times -1, which is -1/2. So at 3 pi, I'm down here at -1/2. So if I wanted to graph this so far, I know that it's going to look like this. Okay, that's gross. Oh well. It's okay. If you look at it, this part right here, I'm going to get my highlighter, make it a little brighter. This part right here is one part of my cosine curve. And if I'm getting through 1/3 of it by the time I get to 2 pi, well, there's 1/4 of it, and then there's a little bit more. So yeah, I guess that is actually kind of like 1/3. Do I expect this to be perfect? Absolutely not. Just try your best. And then I know that if this is going to go back down, then it is going to have to go back up. So if you want, I completely trust you to put this right here and just kind of finish your curve. Alright, because usually after you graph half of it, you can get the gist. 34 was gross. You're probably not going to have a lot of 1/3s to ever do, but it's good that you've finally done it.